Today's mathematics class, we are going to look at the computation with positive integers, particularly place value in ancient number system. Throughout the ages and different countries, we realize that the number system has been developed and has been used to help in counting and also to communicate numbers. Right from the ancient Egypt, we had the modern day Chinese numbering system. Different systems have also been invented, which used pictures and symbols to represent whole numbers. Some of well-known system include the following. We have Egyptian numbering system. We have Babylonian. And we have the Roman number system. So these are, among others, some of the numbering system that existed in the ancient times. So just to illustrate a few, so this is an Egyptian number system, and in the Egyptian time, this was originated in the about 3000 BC. And in this particular case, they used picture-like representation, or we call hieroglyphics. To represent their numbers. They used hieroglyphics to represent their numbers. They grouped the numbers in groups of 10, 100, 1,000, 10,000, 100,000, and 1 million, and so on. For one, it was represented by a stick or a staff. 10 was represented by an arc or a heel bone. This is an arc here. For 100, it was represented with a coil of rope. So we have a coil of rope. This one showing us that this one is 100. For 1,000, it was a lotus flower. A lotus flower looks like this, just like a flower. For 10,000, it was a bent finger or reed. It is illustrated like this. For 100,000, we had a tadpole or a frog, which is a symbol like that. At 1 million, we had a genie. So these are groups of numbers falling between 10 and 1 million, and they were used to represent numbers. In most cases, symbols of the same type were grouped together in twos or in threes and arranged vertically. You'll notice that, for example, here, this is 3. 3, in this particular case, we are supposed to use 1 is 1 stick. So 3, we shall have 3 sticks or staff. This is how we can illustrate 3 in Egyptian number system. For 5, we shall group 5 sticks of 1. That is 5 sticks or 5 staff grouped together to form the letter 5. 21, we shall require 2 tens and a 1, which implies that we shall group together 2 arcs, which represents 20, and a 1 stick, which represents 1. So this represents 21. This number is 342. 342. For 300, we shall have 3 coils, where each coil represents 100. And then we have 2 arcs for 20, another 2 arc for another 20. So 4 arc giving us 40. And then we have 2 sticks, which stands for 2. So the whole of this represents 342. That is how the Egyptian number system used to work. Now, in this case, we used not to have a 0. That's why you realize we are not having a 0 anywhere. We should also notice that it did not use place values the way we do it today. So they are only whole numbers. We don't have place values. We don't have the zeros. So that is it about the Egyptian number system. The next number system we are going to look at is the second one, which we call the Babylonian. So this is the Babylonian number system. It was from about, again, 3000 BC, but mostly when it was about 1750 or 1750 BC, the Babylonians used a very sophisticated number system, and its origin was traced back to 3000 BC. The symbols that were used by the Babylonians were called the cuneiform or wedge shape. The Babylonian used cuneiform or wedge shape. These are the symbols that were used by the Babylonians. You will notice that they are only representing all the numbers using a wedge shape figure. So to represent the numbers here, they had 1, 10, and 60. So for 1, it is a wedge shape, which is upright wedge shape. For 10, it is sideways wedge shape facing my left. For 60, it is upright wedge shape. You realize that 1 and 60, they are all the same. But as we go on, we shall see how to differentiate between 1 and 60. So, for example, we have 5. To represent 5, we shall require wedge shape, which represents 1, 5 times. For 5, we are using 5 wedge shape, upright facing down. 11, we have wedge shape facing sideways. That is for 10, plus 1, which is wedge shape facing upright wedge, which represents 1. So this is 10 plus 1, this is 11. 72, we shall require wedge shape, which represents 60, plus 10, which is 70, and then plus 2 ones. So this is wedge shape representing 60. You'll notice that between the wedge shape here, 60, and the 10, there is a space. This space is what now changes the value of the upright wedge shape to be 60 and not 1. There is a space between this wedge shape and this other for 10. So this one represents 60. Then we have 10, making it 70. Then 2, because they are close, the 2 wedge shape, which stands for 1. So this one is 72. 121, we shall have 2 wedge shape which are upright. But before we write a 1, we shall space. And this spacing is what qualifies the first 2 wedge shape to be 60 and 60, making it 120 plus 1, 121. So symbols were written normally in tables at that time, and they were allowed to dry in the sun. This number system was based on the number of 60, 10, and 1s, as we have seen. And again, the same way, just like Egyptians, we would group the same number values together. That is in the groups of either 10, 60, and 1s. The system is positional. When I say positional, you'll notice that the moment we space this first wedge shape, then the value is 60 because it is spaced before we start bringing in the other ones. So we say the system is positional, meaning that position of each wedge shape helps to differentiate its value. So you'll notice, for example, if I have to illustrate, you'll notice that if I have this wedge shape together, this one represents a 2. But the moment I bring a space, there is a space here. Then this one represents 62. This first wedge shape for 60, and then these are 2 wedge shape for 1 each. That gives us 62. That's why we are saying that this number system was positional. So to represent a 0, because we don't have a 0 here, to represent a 0, they used a blank space, or sometimes a small slant wedge shape for 0 inside a number. But for this particular case, we are going to look at that one, but what we have currently is how to illustrate when we have them grouped together like this. But we shall look at 0 as we go on. So we have the next number system besides the Egyptian and the Roman number system. We have the third one that we call the Roman number system. So the Roman number system. Roman number system is mostly we used capital letters, and they are used, these capital letters that we are used, they were referred to as Roman numbers or Roman numerals. They were developed long, actually about that 3rd century BC, and they have remained dominant up to the current world. In the numbering system, they are still being used in many situations. So in this case, in Roman numbers, you'll notice that we are using these numbers. We have 1, which is simply a capital letter I. We have 5, which is a capital letter V. 10 is represented by a capital letter X. 50 is represented by a capital letter L. 100 represented by a capital letter C. And 500 represented by a capital letter D. 1,000 is represented by a capital letter M. Example, if we want to represent 2, then we shall have 2 capital letters of I. So 2 is represented by 2 capital letter I to give us the value 2. This one is a 4, and for a 4, we represent it as capital letter I and a V. You'll notice that for this, we have I, which stands for 1, and we have V, which stands for 5. It will be noticed that always in Roman number system, a small letter value was placed on the left. So for this particular case here, we can simply agree that we have, it is a, when we write I and V, this is 5, which simply means that a letter with a small value is on the left-hand side of another letter of higher value. So this one is the same as saying 5 minus 1. In Roman number system, if we have smaller letter value on the left, it means subtraction. So this one is the same as 5 minus 1, which is 4. That is how we arrive at IV. Another example would be if we have x. X is for 10. The moment I bring here an I, it is like now saying 10 minus 1, which will refer to, 10 minus 1, which gives us 9. So IX stands for 9. So that is how we look at it. Any small letter on the left of a larger value means subtraction. 21. We have 2 10s and a 1 on the right. So this one is just an addition. So this is 10 plus 10, which is 20, plus 1, which is 21. 59. 50 is L, which is here. Then 9, we don't have the value of 9. 9 is the same as 10 minus a letter. So it will be from here, the whole of this. This one is giving us 10 minus 1, which is 9. So LIX stands for 59. XC. We shall look at C and X and ask ourselves which one carries smaller value than the other one. You'll notice that X from the table here, X stands for 10 while C is for 100. So we say that if a smaller value is on the left, it means subtraction. So for this particular case, we shall take the second value, which is 100, minus the smaller value, which is 10. So XC stands for 100 minus 10, which is 90. That is how we do the numbering using the Roman numbering system. So at this time, let us look at a few exercises. We shall be referring to these charts as we work out those problems. Question says, write 3, 15, and 44. So write 3, 15, and 44 in the given number system. The number system we have are 3. The first one we have the Egyptian. So we shall start with the Egyptian. We want to represent 3, and then 15, and then 44 using the Egyptian. Now, looking at our charts before we start off, this is the Egyptian. 1 is a stick. So to represent 3, we require how many sticks? 3 sticks. So we shall find that to represent these 3, it will be represented in the Egyptian number system as 3 sticks grouped together. If it was a 5, to represent 5, it will be represented 5 we don't have the value of 5 here, so we shall have to use groupings of sticks to show 5s, and we shall require 5 sticks. So we shall group together, those are 3 sticks, and then down here 2 sticks. Total of 5 sticks gives us the value of 5. The other one was 44. 3, sorry.
We tackled 3.
So for 15, that was for 5. For 15, in Egyptian number system, we shall look at this. We have the value of 10. We don't have a 5, but we have a 1. So this we shall require 1 arc, which stands for 10. That is a 10. And then we require, to make it 15, we shall require 5 sticks or staff. So we have the first one, second and third, and then we have the other 2 down here. So this one stands for 15 in Egyptian number system. For the last one, 44. 44, we are looking at this. We don't have a 50, we only have 100 and onwards. So we shall group together 4 arcs to make it 40. So 4 arcs, this is the first arc, second, third, and fourth. This one is equivalent to 40, but we require 44. So we shall come in and bring in, those are 4 sticks. These are 4 arcs, 40, 4 sticks giving us 4. 4 plus 40 is 44. That is how we represent 44 in an Egyptian number system. So write 3, 15, and 44 in the given number system, and this time the second one is the Babylonian. In the Babylonian number system, we are using wedge shape, and these wedge shape symbols are only for 1, 10, and 60. 1, 10, and 60. And we want to represent 3 here, then 15, and then 44. So to start with 3, to represent a 3, for 1, it's 1 wedge shape. So we shall require only 3 wedge shapes to give us a 3. So we have got 3 wedge shapes, which stands for 3 times of 1. This gives us the value of 3. For 15, before we start working on it, we have a 10 and we have 1. The other down is 60. So we are going to concentrate on the first wedge shape and the second one. So we require a wedge shape that gives us 10. And for a 10, it's a sideways wedge, which will and then we don't leave any space. We need to bring in 5 more wedge shape, upright wedge shape, to give us 15. So we have a 10 plus 5. This one is giving us in Babylonian an equivalent of the value of 15. 1 sideways wedge and 5 upright wedge. The last one we have is 44. So to represent 44, we require sideways, which is 4 of them to make it 40. And then we shall require 4 of this to make it 44. So this one will be illustrated as we have sideways, take note the direction of the wedge matters a lot. But I've not left space, so this one is sideways wedge, which implies that this is equivalent to 10, 20, 30, and 40. Then for the remaining 4, to make it 44, it's upright wedge without a space. So that is what we have. This represents 44 in the Babylonian number system. Now, coming to the third number system of the Roman representation, we are going to represent again the same numbers in Roman number system. Now, in Roman, what we have, we normally represent them using letters. So to represent 3, we require 3 capital I's. So 3 will be equivalent to 3 times the I. So this one represents 3. For 15, we shall require a 10 and we shall require a 5. I want you to note that in this case, in Roman, we don't add. If you write here as 5 plus 10, this is 5 and 10. This is not 15. We said in Roman, if a smaller value is placed on the left of a larger value, we subtract. So this one is the same as saying 10 minus 5. So it's not going to give us 15. But for 15, we start with the larger value, which is 10, and then the V, which stands for 5. So this one is 15. The last one, which is 44, to represent 44 in Roman way, we shall require to have 40. And to get 40, we cannot have x all the way up to 4 times, but because we have 50. So 50 minus x gives us 40. So we shall have, for 44, we shall require a smaller value on the left and a larger value on the right. Larger value is 50. Smaller value here is 10. So 50 minus 10 is 40. Then we require 4. 4 is slightly below 5, which means it's 5 minus 1. So we shall bring in an I and a V. So this one will simply mean that this one is 50 minus 10, which is 40, and this one is 5 minus 1, which is 4. So this one is a total of 44. Another question, what number do the groups of symbols represent? So, and the group of this, the following is what we are looking at. We have so we shall handle each one independently. What number do the group of the symbol that we have here represent? So the first thing we need to identify is to know what group of number system does these symbols represent. Is it the Romans? Looking at the Romans, it's not. Is it going to be the Babylonian? Looking at the Babylonian, we need the wedge shape, it is not there. So definitely it is an Egyptian system of numbering. So in the Egyptian system, when we have an arc, it means a 10. When we have a stick, it means a 1. Then we have 3 arcs and 3 sticks. So simply, in this particular case, we find that 3 arcs stands for 30 and 3 sticks stands for 3. So the value of this group of symbols is 33, and it is, remember, it is an Egyptian system of numbering. So we have a coil, an arc, and a 1. A coil, an arc, and a 1. What would this represent? We need to identify what figure or what value does a coil stand for. And then what value does an arc stand for? Looking from the symbols, definitely it tells us this is an Egyptian number system. An arc stands for 100. We have 100, so we can simply say this is 100 plus. We have, this is a coil for 100, then an arc, which stands for 10. We bring in a 10. plus 1 stick, which stands for 1. So the value of these Babylonian symbols is 111. This one is the value of this particular symbol. So we have it in Egyptian and we have it in ordinary figures. The last group of Babylonian example handled, the third one. So we have a coil, another coil, and then we have 4 arcs, and then we have a 1. From what we have seen, a coil stands for 100, an arc stands for 10, and a stick stands for 1. So when we have 2 coils, this one simply means this is 100 times 2, which is 200 plus. We have 4 arcs, and an arc stands for 10, so these are 4 arcs, which is 40, and then plus 1 stick, which is 1. So this Egyptian number system stands for 241. 241. Now, the second group now is the number that the following group of the Babylonian stands for. This was the Egyptian, so let us look at the following. What does the following symbol stand for? We have the first one, an arc, side arc. So that is the first one. Side arc and 2 upright arcs. Looking at our diagrams with our chart, we have 3 arcs here. Upright arc stands for a 1, and side arc stands for 10. For this particular case, it's straightforward. The first one is for a 10, and the second one is, there are 2 stands for 1 plus 1, which is 2. So this one simply means that it is the value of this Babylonian number system is equivalent to 12. It is equivalent to 12. We can also look at the next. This time round, we have upright arc. Now, I want you to be very keen here. We have the first 3 wedge shape. There is a space here, then sideways wedge shape, and then upright wedge shape. The main reason why we need to be keen is there is a space after the first upright wedge before we start the other group. And that's why we say that in Babylonian number system, the positioning of the arc of the wedge shape is very important. So, looking at the diagram, we have this one as 1 and the same shape also as 60. I said earlier on, the positioning varies. So because we have put here upright wedge shape, but we have spaced, then it means we shall not treat this wedge shape as a 1, but we shall treat it as a 60 and leave a space now to start the other group of wedge shape. So this one refers to 60, and it is 60 how many times? 3 times. This one is each arc, each wedge shape, side wedge shape is 10. So this 10, 3 times. Upright wedge shape 5 times gives us 5. So we shall find that the value of this will be equivalent to 60 times 3, which is 180, plus 10 times 3, which is 30, then plus 5 times 1, which is 5. So this one gives us 215. 215. We've arrived at 180 because there is a space that is left before we start the other one. That makes this wedge shape, which is upright, as 60 and not as 1. In the last part of the Roman number system, we shall look at a few examples, this time on Roman number system. We need to represent the following. What does I and V stand for? As we said earlier on, the moment a smaller value is on the left of a larger value, we subtract. So larger value here, we start with from the right, larger value is 5 minus smaller value, which is an I, and I is 1. This one gives us a 4. So this IV stands for the value of 4. We have V and I 3 times. V and I 3 times. When you have smaller value of Roman number on the right, it means addition. So this one is 5 plus 3. So you expect this one 5 plus 3, which gives us the value of 8. Take note that on the left-hand side, we only allow one value. You cannot bring in and say this can be twice smaller value and then a larger value. It cannot. We only allow one small value. That's why we can only have either IV or for 4 or maybe XL if we want to illustrate for 40. Only one smaller value and a larger value. If we want to represent 16, so we have, this is a larger value followed by another smaller one. So this one we are going to add, and then followed by much more smaller. So this one is the same as 10 plus 5 plus 1, which is 16. We have the last one as 40. We have already seen it here. XL, we are asking ourselves which one is smaller than the other one here. If the smaller one is on the left, we subtract. So X is smaller than L, and X stands for 10, L stands for 50. So this is the same as 50 minus 10, which is 40. That is what we find when you are using the Roman numbering system. So there's a problem to be solved. You have been given in Roman numbers, subtract XIV, subtract XXII from XIV. For us to work out this, we first need to convert it into ordinary number system and then subtract, and then we change. We should leave the answer for this in Roman number system. So first we ask ourselves, the first piece stands for what? This is 10, and this is 1, this is 5. Because 1 is on the left of 5, so this is 5 minus 1. So we realize that this one gives us 10 plus 4, which is 14, minus 10, we have, this is 10, this is 10, and this is 2. So this is the equivalent to 22. So we have a small value being subtracted, subtracting a larger value from a small value. This one is equivalent to 22. This one is equivalent to 14. When you subtract this, you will find that what you will get is a negative. You'll find that what you get is a negative 8. But this 8 is not supposed to be represented as in ordinary number system, but in Roman number system. From the chart that we had, for us to represent an 8, we shall require a 5 and 3 other i's. This is an 8, but it's supposed to be negative. So this one in Roman number is like that. For the second part, we have two coils. So they are asking us to subtract these symbols from these symbols. This is the Egyptian number system. We need to know their values. A coil stands for 100, an arc stands for 10, a stick stands for 1. So there are two coils, that is 200, one arc, which is 10, that is 210, plus 2, so this one stands for 212. These are two coils, an arc, and two sticks. Minus, we have four coils, which is 40, plus 1, which is 41. That is what we have. And when you subtract this one, you'll find that the value you get is 171. Again, we need to represent this in form of the Egyptian number system. 100, we have the value as a coil, so we shall have a coil here. Now we have 100, we are remaining with 71. Now for our case, we only have arcs, and the arcs represents, represented here, we have arcs, which stands for 10. So we need to have arcs that will give us an equivalent of 70. An equivalent of 70. So we shall have arcs running here. These are 7 arcs, 10, 20, 30, 40, 50, 60, 70, plus 100, that's 170, and then we shall have one stick, this one giving us 171. That is how we shall represent the answer in Egyptian form. The last one in Babylonian. So we have this symbol minus that symbol. Earlier on, I said the moment we have spaces in the Babylonian, it gives the value of a wedge a different value. So we have a space here, which implies that the first wedge, upright wedge shape, stands for 60. Then this is sideway wedge shape, which stands for 10. This one is for 1, so this is 3. Minus these are sideways, which is 10 times 3, 30, plus 1. So this one, you'll find that it is 73 minus 31. 73 minus 31. Now, we simply subtract in an ordinary way, where you'll find the answer is 42. And for us to represent again 42 here, we shall be required again to convert this into Babylonian. And for us to get this one, we shall require 4 side wedge shape and 2 upright wedge shape. So this 10 is the same as so these are side wedge shapes, which is giving us 40. And then for 2, we shall have upright. So this is 42. Now, considering the issue of the space, we want to put the following clear about spaces when it comes to Babylonian number system. we notice that the difference between 1 and 60 cannot be seen when we look at the shape. 1 is simply given as upright wedge shape. 60 is also given as upright wedge shape. But now we need to bring a clear difference between these two. So the difference here is by simply the spaces that you give. Now, if I give upright wedge shape and I leave it like that, this one is a 1. This one is a 1. Now, if I have a wedge shape facing up just like the other one, and then take note of the spaces I want to give. There are 6 spaces I've left here. These 6 spaces is trying to tell us that this is the upright wedge shape, but it is not a 1, but it is for a 60. So to represent a 60, we require an upright wedge shape, but we shall leave 6 spaces on the right hand side. When we want to represent 3,600, this is a large figure. To represent this, we shall have upright wedge shape, and then we'll notice that we shall not have another wedge shape. Instead, we want to have multiple of 60. So we shall give 6 spaces. First 6 spaces for 60, and then the multiple of the second 6 spaces, we leave a little space and we give another 6 spaces. So these are a total of about 12 spaces. So this one is a multiple of 60. So this is 3,600. That's how space in Babylonian numbering system is very important. So what are we trying to say here? The 0 here was used, we are trying to bring in a 0, but because we cannot write a 0 using that format, we normally indicate the spaces. So people, you would actually know what it's meant depending on the number of spaces or the situation that has been used. So these spaces that we are leaving represents the value of that particular number. That is it about the Babylonian number system. Now, your assignment about the number system. So other well-known number systems that existed include the following. We have the modern Chinese, other well-known number systems that existed, we have the Mayan, modern Chinese, and ancient Greek. Now, the assignment here, look up onto your internet or any other source that you can be able to find the information about the 3-number system. And in your research, you should be able to give a brief statement about the following. So as you do your research on Mayan, modern Chinese, and ancient Greek, write brief notes on when and where were they used. 2, what symbols were used. And 3, examples of numbers using this number system or these symbols. That is it for today about the ancient number system. In our next class, we shall be looking at the place values in Hindu-Arabic numbers. Thank you.